Good morning, students. You are highly welcome in today's lesson. It's a pleasure to have you once again in my class. We use this opportunity to appreciate or thank our fellow friends and well-wishers at home. Remain blessed as you join us in our lesson today. Before we start, I want to introduce myself. My name is Mrs. Ikara Blessing, or you can call me Teacher Blessing. Okay, before we proceed to the lesson of today, I just have a single question for you. What means did you come to school this morning? How did you come to school this morning? As we all knew that some come to school with their private cars, some come with school buses, some trekked to school. And in the aspect of trekking to school, we discover even those that come with private cars, there is a distance between the school and from their residence. And that will lead us to the topic of this morning. Okay? That is variation. When we talk about variation, variation is a branch of mathematics that shows the relationship between quantities. Variation is a branch of mathematics that shows the relationship between quantities. And we'll be looking at this objective. Today, the specific objective at the end of this lesson is expected that the student will be able to state that rotation gives rise to variation, as I explained from the beginning of this lesson. Number 2, write down the equation showing direct variation. And lastly, solve for a given variable in a direct variation given the value of others. Okay, having seen the specific objective before now let's have this in mind, that the variation is a branch of mathematics that shows relationship between quantities, and it is denoted by alpha. In this topic, we have types of variation. We have about 4 types of variation, but today we'll be focusing our attention on this particular. So in variation, we have about 4 types of variation, but today's one will be focusing our attention on this number 1 that says direct variation. This is where we'll be focusing our attention for today's lesson, direct variation. Okay? Okay, as we can see what is on the board, as I told you that today's one will be specifying on direct variation. Now let's look at the meaning of direct variation. Looking at the board, direct variation is said to be a relationship, is said to be a relationship between 2 variables in which one is constant. Did you get that? Direct variation is said to be a relationship between 2 variables in which one is constant. Now let's take one example so that you understand it better. Example 1. We said T varies directly as R in an experiment. When T is equals to 8, R is 2. Now they said find the value of R when T is equals to 4. Okay, we'll take in solving, we'll be taking it bit by bit. The first thing we ought to do is to state the formula. Okay, we ought to state the formula. Now, looking at how the sentence goes, T varies. Pick the first letter that you heard, which is T. Okay, T. Now, introduce the formula or the sign or the symbol of variation. T varies directly as R. Introduce your symbol, which is alpha. and complete the other variables, because I told you that it's a relationship between two variables. You cannot go with one variable. Two or more variables must be included. So t varies directly as our r. So this is the formula for this direct variation. T varies directly as r. So the next thing to do is, as I told you at the end of that definition, we said that one of the variable must be constant. Now, the next thing to do is to introduce our constant. How do we introduce our constant? You continue. T varies directly as, introduce your constant, which is k. So k here, as I've made you to understand that in your solution you have to pick the variables according to how they are stated. We have picked the first variable, which is t, and introduced our symbols of a variation, which is alpha here, and brought in the last variable, which is r. Now, for we to introduce our constants, the sign of this alpha ought to change to the sign of equality. Okay, I hope you are following me. Now, it will now be t is equals to, introduce your constant, which is k. It will now be kr. Now, let's take up the proper equation. For we to take our proper equation, your k, which is your constant, have to be the subject of the formula. Okay? Your k, which is your constant, have to be the subject of the formula. And if it appears as the subject of the formula, we will have k is equals to your t will cross over. It will now be tr. That is involved in this lesson. Okay, we are at this point now. Now, all we need to do is to make our k, which is the constant, the subject of the formula. And by making it the subject of the formula, we divide both sides by r. And when we divide both sides by r, we ought to have k is equals to t over r. Now, the next thing to do now is to apply the values of those variables. Okay? We ought to apply the values of those variables. Okay? I hope you are following me. Okay? This is our k now. It has been made as the subject of the formula. K is equals to t over. So the next thing to do now is to bring in the values of those variables that has already been given. So what we are looking for here is k, which means k is equals to our t. The value of t here is 8. All over the value of r is 2. And that means that our k is equals to 4. So we have gotten our constant now as 4, which is k. Now the next thing to do is to go back to that formula given to us and introduce the value of our constant into it. And that is t is equals to k r. We have gotten our k now, whereby t is equals to 4r. And this is our equation. Second phase. Okay, we have gotten the first phase of that example and the values of the variable given. The next thing to do now is to get the second phase of the example given, whereby they said they gave us the values of those variables that we should find So this is the second phase of the example. The variables we are given. Remember the formula we are using. Introduce the values given to the variables again. We have gotten our k as 4. T here is given, but r is not given. So what we are looking for here is r. For we to get our r, we have to do cross multiplication. In cross multiplication like this, we will have 4r is equals to 4. Now divide both sides. For we to get our R in which we are looking for, we have to divide both sides by the coefficient of R, and the coefficient of our R here is 4. So we have now we have our R separate is equals to 4 divided 4 to give us 1. So our R here is 1. If you look at what we have solved, you discover that it's not even a difficult task. At this junction, I think you have understood what I have given you this afternoon. Thereby, I ought to give you at least one example to solve. Okay? Okay, this will bring us to the end of the lesson for today. Before then, remember that we said that at the beginning of this lesson that we have 3 things to look at. Number 1, that students will be able to state the mutation that gives rise to variation, which we have done. When we talk about variation, it talks about distance. And through that distance, brought about what we looked into this morning, variation. It gives rise to variation. When someone walks, when somebody is walking on the road, the more closer you are going to your destination, the more time you are spending. That is mutation that gives rise to variation. And number 2, we say that we should know how to write the equations, which we have done today, and at the last solve problems that deals with direct variation, which one has been given to you already on the board. Look at the question that says, under the direct variation, P varies directly as Q when P is 3, Q is 9. Find the value of P when Q is 4 and 9 when P is 8. Okay? This will bring us to the end of the lesson today. When next we gather, we'll continue from the next topic that says inverse derivation. Thank you.